Alright, welcome everybody. I'm going to solve a test 1, statistics. And the topics we're going to be going over, or the topics that were on this test, are basically measures of center and dispersion. We're going to solve this test. So let's see. Number 1, what's it say? Explain the difference. Let's see if I can increase this font. Kind of. I can kind of increase that font. Alright, let's see. Explain the difference between a population and sample. Alright, a population is basically everyone, and a sample is a subset. So let's see. It says correct answer. A population is the entire group that is being studied, while a sample is a subset of the population that is being studied. Alright, number 2. So it's a fill in the blank. You have 2 answers. So okay, so let's see what's going on here. So the correct answer for stat 1, so descriptive statistics consists of organizing and summarizing information collected, while blank statistics uses methods to generalize results obtained from a sample to the population and measure the reliability of the results. So generalize results obtained from the sample to the population. That is inferential statistics. That is the definition of inferential statistics, when you generalize results from a sample to the population. Number 3, true or false, the following is a designed experiment. A study is conducted to determine if there is a relationship between brain cancer and use of cell phones. Doctors ask patients with brain cancer about their use of cell phones. This is not, it's not an experiment, because it's just an observational study. They're just asking them questions about how much they use their phone. Alright, next one, number 4, I think this is. What does single blind and double blind mean? Let's see, I had a Word document somewhere. I was writing that down for number 4. I just put single blind means participants don't know the treatment. Double blind means participants and those administering the treatments don't know the treatment. When I say don't know the treatment, I really mean don't know which treatment is real and which is the placebo, something like that. Alright, so that's good. Number 5. Let's see, what's number 5? Number 5. It's asking to do 2 things. Number 1, well, there's 2 options here. So you either got this question or you got this question. So for this question, it says, this one's asking for a frequency distribution for blood types. See homework 24 on 2.1. Let's see. Homework 24 on 2.1. Let's go there. Let's go to my math lab. Oops. My math lab. Homework 24 on 2.5, or what was it? So I'm going to open StatCrunch. I'm going to go data sets from your textbook. Chapter 2, I think it was. And which one was it? Where were we? Here. 24 from 2.1. Okay. 24. There it is. What do they want us to do with that? Make a frequency distribution? Create a bar graph for this data. Okay. Bar graph. Let's just go to graph, bar graph, or bar plot. We have data, not summary. So click that. And that's it. There you have it. That's your answer. I'm going to copy that image. Put that in there. And that was it, man. That's how you do that one. Move this down here a little bit. Oh, you know what? I'm gonna insert some table with 3 answers. Put this here. Put 5 here. And I'll do this. Actually, I don't think I needed a bar graph, did I? I needed a frequency distribution for blood types. frequency distribution. So for that, we can go to stat, summary stats, or no, not summary stats, tables, stat, tables, frequency, bud type. We just need a frequency distribution. So let's actually, I think we just need that instead, frequency distribution. So I'm going to copy that. New, copy, word, paste, get rid of this bar graph because we didn't need it after all. Minimize that, throw this over here. Alright, so that's one version of the test. You had to do that. The other version of the test, you had to copy this. It says create a bar graph. So this one, they want a bar graph for this one. So I'm gonna, let's see if I can copy this data. I'm going to say Control C, copy, and then I'm gonna go to Word. Or actually, no, I want to go to StatCrunch, don't I? Let's just go here. Close all this. Go here, press Control V. Ah, I put the A right there. No, I don't like that. Let's put it. Go here and press Control V there. Okay, let me get rid of this one. Delete column. So I want that. I'm gonna just call that data. I want a bar graph, so I'm gonna go to graph, bar plot, graph, bar plot with data. We want data, right? And that's it. There you have it. So I'm gonna. That's what I want. Copy image. That's a bar graph. This one is asking for a bar graph, but it's different data. So in this one, A has 18, but on this one, A only has 9. See the differences? Different data. Alright, that's number 5. Number 6 is a histogram. So here we have Facebook's. By the way, let me see this one. Which one is which? So this is blood types. That's number 4. Okay. For this one, you have what do you ask to do with histogram? First lower class limit of 0, class width of 0.5. Got it. So we want a histogram with the first. Okay, so I'm gonna go Control C, copy that. Go back here. I'm gonna put this right here. Control V. And we gotta make a histogram. So, but it's specific. So we're gonna bin this data, because if you look at the question, it says where did it go? Over here. Alright. It says the following are the rates of return of Facebook stock, with a first class having a lower class limit of 0 and a class width of 0.5. Construct a frequency distribution. Oh, we don't need a histogram. We need a frequency distribution. Okay, I almost made a histogram. Oops. So frequency distribution 0, 0.5. Okay. So I'm gonna do wherever StatCrunch is. I'm gonna go to data and bin. Data bin. Fixed widths. I'm gonna pick this guy. That's where we wanted it, right? Variable 5. Yeah. Start at 0 and then 0.5. That's what they said. And then we're always gonna include the left endpoint. So just press compute. That's it. There you have it. Those are the bins. It's putting all of these data values. It's classifying. 0.425 is in between 0 and 0.5, so it goes in that bin. But 2 is in between 2 and 2.5, so it goes in a different bin. Now I'm just going to do graph. What do I want to do? We want a frequency distribution, so we don't want a graph. We want a table. We're creating a table, frequency table, with the binned data. The binned data, right? So binned data. And we just need a frequency distribution. We don't need a relative frequency distribution. Looks like we just need that. And that would be the answer. So let me copy it. No. Grab that. Go back to Word. This is, what is this? Is it 6? I don't know if this is 6. It could be. But I'm gonna Control V that. Paste that. I'm gonna copy this. And I'm gonna paste it right here. I'm gonna change this to 6, get rid of that, and I'm gonna go here, get rid of that. For the other version of the question, I'm going to go back And it says, oh, same thing, Facebook stock 0.5, different data set. I'm gonna grab this and I'm gonna press Control C. Move this out of the way so you get to see it again. So I go here, press Control V. I'm gonna call this new, and I'm gonna do the same thing. Data, bin, same widths, but I want new. 0.5, right? I think same class widths and everything. Yeah, same class widths because it says that 0 and 0.5. Okay, and now we're just gonna do the same thing. Stat tables, frequency. Click new. We only want the frequency distribution. Compute, and that's it. Whoa, lots of unique. Oh, whoa! Did I use new or did I use the wrong one? I want to use the. Oh, look, see. When it gives you something like an error message like that, you know you did something wrong. I put in new. I should have been new. So let me see. Can I delete all these things? I'm gonna create a new table soon. So tables. I mean a new worksheet. Tables, frequency. I need new. There it is. And then just the frequency distribution. Compute. That's what I wanted. I'm gonna go to copy, new. Do that. Go to Word, Control V. That's the other version. Okay, that was the other version. So Facebook's. Okay, that was the Facebook question. So let me go back to Word and just say Facebook. And then what are we on? Number 7. Let's see what else is on this test. I think this is 7. So this one's talking about college grads, and we want to create a frequency polygon of this data with 35,000 and 5,000. Okay, let's do it. Grab this data, Control C, copy that, go back to stat. I think we should get rid of this. Is there anybody? Let me just create a new one. Just click any data set. I'm gonna delete this. Delete. Start fresh. Go here, Control V. What is this? Income or something? I think it was incomes. Frequency polygon. To make we have 35,000 and 5,000. We gotta bin it. We gotta go to bin. Get income. 35, 1, 2, 3, 5, 1, 2, 3. Include the left endpoints. Good. What are we making? A frequency distribution. So we're gonna need a table. We're gonna use the bins. Frequency, compute. Now here's the hard part. This is a frequency polygon, so I'm gonna Control C that. Go here, Control V. I need the midpoints for the frequency polygon. So between 35 and 40. What's a good way to get these midpoints? It's kind of hard, but the midpoint between 35 and 40. Is there? You know what? Huh? Nah, I'm not gonna try to come up with a way right now. But if I add 35 plus 40, it's 2.5, so 37.5. So 37,500. Wait, it's not typing in. 37,500 would be the midpoint. The midpoint here would be 42,500. 42,500. 52,500. 57,500, 62,500, 67,500, 72,500. Those are midpoints, frequency polygons. So it's going. What's it going? I'm gonna put a 0 here and then a 0 down here, and then I'm gonna go here and put what 77,500. And then if I have to subtract, go down to the 232. 32,500. 32,500. Let me see if this makes sense. 35. Yeah, it's the difference of 5, so that's 2,500 because it's what 5,000. So 2,500. So this one should be 32,500. So they're all 500. So it's going 32, 37, 42. Ooh, this should be 47. I'm thinking. 42. Wow. There's a missing thing here. Look at that. There's a missing group. Interesting. There's 0 in that group, and that's okay. But 40 to 45 would be 42, and then 50 to 55 is 52. Yeah, there's a missing class here, missing bin, because there were 0 values in there. So that's okay, because we're still gonna work with it. There's 0 in there, so technically it could go down to 0, or you can just not have it. So interesting. I would accept both of those answers. If you included another row here of 0, that would be fine with me. But let's see, you got 35, 40, 45 is missing, 50, 55, 60, 65, 70. So we're missing a class there. So if anybody put that in as their answer, I'd give it to you correct. But alright, so oops. So once we have all this data plugged in, we're ready to go. We go to graph, chart, and then we'll pick columns, and then we're trying to graph, let's see, variable 5 would be the frequencies, and the rows are in, and that's it. Well, we want to pick points with connected lines. So this is chart. Alright, and that's it. Compute. There you have it. So that would work. Copy image. Word. Let's see here. Can I insert another row? Call this 7. I think this is number 7. Go here. Control V. Alright, there's that one. Okay, go back to the tests, or actually we want to go back to, yeah, test. So this one says, okay, SMC grad. Alright, another one, same thing. It says, what does it say? Frequency polygon, make a frequency polygon. So grab this data, Control C, go back to StatCrunch, close some things. We could probably start a new, kind of want to just go to a regular StatCrunch. Open StatCrunch. Yeah, fresh page. So I'm gonna go Control V. I'm gonna go to data, bin. I'm gonna click variable 1. I'm gonna start at 35,000 and then 5, 1, 2, 3. Compute. Good. Now what do I need to do? I need to make a table, frequency table with the bins. And then I'm just gonna press compute. I'm gonna grab this data here, Control C, go here, Control V, up here I'm gonna put a 0, down here I'm gonna put a 0. Now what are the midpoints? It's gotta be an easier way to get these midpoints, man. What if I go to try something just for fun? Compute expression. I don't know if this is probably not gonna work, but if I go to M for midpoint, there's no good thing for midpoint, huh? How about median? Median will work. Look at all those M's. What about median of, yes, it's not gonna work. Trying to be creative. Median on variable var. Let's see. No, it did not work. Okay. Okay. It's gotta be a better way to do this. Like I could just say 35, 1, 2, 3, 40, 1, 2, 3, and then 40, 1, 2, 3. Try to come up with a way. And then 45, 1, 2, 3. This is kind of time consuming though. 50, 1, 2, 3. 55, 1, 2, 3. 55, 1, 2, 3. 60, 1, 2, 3. 60, 1, 2, 3. 65, 1, 2, 3. I mean, if you really wanted to do something like this, you could go to data, compute, expression. You could say like, where did I put those in? I put them in bar 6, bar 7. You know what I'm gonna do? I'm gonna call this like X and Y to make it easier on me. So then I'm gonna say X plus Y divided by 2. There you go. Got the midpoints now. See? So that's just a little trick if you wanted to do that. And then I could just grab this data. Can I do this? Control C, Control V. Yeah, I can do that. Nice, nice. So then, yeah, I'm gonna put I need to add one class to the top and bottom. So go to 32. They're going 37, 42. So there's 2, 2, then 7, 7. I'm gonna go 32, 500. Seeing the pattern, but something interesting that happens because there's, see the 2, then 7, 2, 7. There's no 7 here, so something interesting happens. It's missing a class here, and that's okay. So if you want to insert a class, that's fine. But it's missing a class there because it's going 2 to 2. See that? It's a difference of 10,000 between those. But here I'm going to put 67, 500. You can just ignore that. And then graph chart, columns. I'm trying to graph variable 9. Those are the frequencies. I want to graph the frequencies. These are just on the x-axis. So really it's kind of like frequencies, and these are just like, over here we call these the midpoints. So rows are the midpoints. I'm graphing the frequencies. That's it. Definitely want to change this to points with connected lines if we're doing a frequency polygon. So there you have it. Copy the image, paste it, size it, and let's call this SMC grad incomes. That's what that was. Okay, so let's insert a row. Insert row, insert below. Let's see if there's a number 8 that we gotta do. Alright, next question. Average question. Okay, Professor Kim, got it. 9 people. How am I gonna do this? I can do it on Word. So 9 people had an average of 86. Got it. 9 people had an average of 86. The exam score, one of the exams was missing. It was 72. So let me see if I could do this. Where do I want to do this on Word? Let's see, 9 people had an average score of 86. So from that, I'm gonna say, sum divided by 9 equals 86. And I'm gonna say sum equals to, what's 86 times 9? Let me just pull a calculator up for that. Okay. Ah, this battery's dead. Battery's dead on the calculator. How about this one? 86 times 9. 86 times 9 equals to 774. The sum is 774. Now that's for the sum of the 9. So if I want to, I can say underscore 9 here or something like that. The sum of the 9. Now the 10th score was what again? Let's go back to the test. 72. There was a missing exam. It was 72. What's the new average? Okay. Okay, so basically the sum of the 9 plus 72, that would be the total score of the 10 scores. So if I just add all those up and divide by 10. And that's going to be equal to 774 plus 71. So what's 774 plus 771? 774 plus 71. 845 divided by 10, that's 84.5. So 845 divided by 10 equals to 84.5. Alright, that's that. That's the average for the 10 tests. Now, what's this one? Same idea. This time it's 82. Let's see, 82. Let's try this. 82. So 82 times 9, what is it? 738. Okay, so the missing score was 68, I believe. Was it? Let's check. Yeah, 68, so same stuff. Now if I add the 738 plus 68, what do I get? 738 plus 68 equals to that, 806. So this is now 806. So 80.6. Okay, this one good. Now what type of questions was this? This is a missing score was 68. Okay, missing score was 68. Got it. All right, insert another row. How do we do that? Right click, insert below. Call this number 9. All right. So, okay, what's going on here? It's kind of hard to read that, but in this picture is a histogram that is right skewed. So the mean is bigger because the mean chases the tail. So the mean would be to the right. So the mean is greater than the median because it's symmetric. No, it's skewed right, so it's got to be one of these. It's got to be that one. So I guess that one we don't really need to do. Alright, moving on, because that one's a multiple choice question. Moving on, we have a matching. So here the second summary statistics is different than the other 3 because it is 62 and all the other ones are 52. So the one with 62 would be probably this one because the middle is around 62. So for A, it's 2, so 2 is A. And then you look at this 1.6 and this 24, the biggest and smallest standard deviations. I have this video already if you want to check it out. Go ahead, just look up matching summary statistics. Just Google that and this video will basically come up. Yeah, so which one, like this, notice this range is the biggest. So this would be 4, B. So 4 is B. And then the other ones you can kind of figure out using those ideas. Alright, so for this question, it says it's a numerical question. So it's saying the average age of COVID-19 cases in 2020 was 38 with a standard deviation of 12. Assuming that ages have a bell-shaped distribution, what % of people had ages between 26 and 50? Okay, so it says that it's bell-shaped. That's a big hint. That means it's the empirical rule. Also, the answer is 68, so that's a dead giveaway to me. So basically these two numbers, 26 and 50, they are 1 standard deviation away from the mean. Notice that the mean is 38, so if I add the standard deviation, which is 12, if I add 12 to 38, I get 50. And that's what that is, 50. So that's I added 1 standard deviation to 38. If I subtract 12 from 38, I must be getting 26, which it does. And that's why the answer is 68, because the empirical rule. This is bell-shaped, so the empirical rule applies. The empirical rule is also known as the 68, 95, 99.7 rule. Alright, next. The average age of COVID-19 cases in June 2020 was 38 with a standard deviation of 12. The same question. Assuming that ages have a bell-shaped distribution, 95% of ages of COVID-19 would be between which two ages? So I'm going to take 38 and 12. So 95 would be for the 2. I'm going to add and subtract 2. So let's remember it's 12 and 38. Let's go back. 12 and 38. 12 and 38. So I'm going to say 38 minus 2 times 12 equals to what? 38 minus 24. That's 14. And then 38 plus 2 times 12 equals 2. 38 plus 24, 62. There you go. That's that question. I don't think that's number 9. I lost track. Could be 12 or something. I'm not sure. But let's see. We're going to insert another row below. Say like number 13. I don't know. We'll see. All right. Tests. 13. This is where we are. The average number of home runs per year by baseball players is 13. That's the average with a standard deviation of 4. What percentage of players would have home runs between 3 standard deviations of the mean? So that doesn't say bell-shaped, right? Remember the last one said bell-shaped? Alright, so this is Chebyshev's theorem. So And this is saying between 3 standard deviations, so I'm just going to plug into the formula for Chebyshev's theorem. So we're going to go over here and just say 1 minus 1 over 3 squared, right? Which equals 1 minus, which equals 1 minus 1 over 9, which is 8 over 9, which is approximately 0.89. I really want to say approximately here. How do I say approximately? Besides using inserting symbols, I'm gonna resort to symbols here. Resort to symbols. Ah, that's weird. Hard to find them all. Ah, okay. Okay. Wow. I don't see it. So I'm gonna go here instead. Easier way to do it. Insert equation. Oh no. Inserting equation there? I just want a symbol. Let's do it like this. Equation. Where's approximate? It's easier to find here. There it is. Now let's just copy this. Control C. Oh wow. Really put it in like that, huh? Interesting. Huh. Alright. Okay. So, sorry about that, but the answer is around 89%. Now let me do this. I'll insert another row. Moving along. 14. Let's see. Okay, that was that one. Now look. Oh, is that it for those? Let's see. Yeah, that's it. For this data set, what would you use to estimate the center and why? This is the hardest question in the test. What would you use to estimate the center and why? Copy. Go to StatCrunch. Let's go to a new StatCrunch. Oh, okay. Open StatCrunch. So, put this here. Now, what I'm going to do is just graph histogram. Pick that, press compute. Bang, it's right skewed. When it's right skewed, I need to use the median and IQR for the dispersion. Use the median and IQR. Let me move this. If it's symmetric, I'm going to use the mean and standard deviation. And that's the answer. So this is obviously right skewed. You have a tail to the right. A well-defined tail to the right. This is definitely right skewed. So I'm going to go back to, let's see. It says, for this data, what would you use to estimate the center and why? I'm going to say, use the median, since the data is skewed right. Okay, number 15. Insert below. Use the IQR since the data is skewed right. For number 15 says right here, for this data, what would you use to estimate the dispersion and why? Note that this is the same data set as the previous question. Alright, so that's it. Now for this one, we're almost, how many questions we got left? Let's see. Check the following data set for an outlier. If there is, show why it is an outlier. Okay, we gotta check this for an outlier. I'm gonna grab this data. Oh, this is the last question? No, it's not. Alright. Copy. Go here. Close this. Open. Control V. Graph. Box plot. Well, this is just to kind of show you guys, hey, there is an outlier. Okay, there's an outlier, but I still need to do stat. Summary stats. Column. Variable 1, I need Q1 and Q3. That's pretty much all I need is Q1 and Q3. for this stuff. So Q1 and Q3 are right there. So 50 point. Okay, let me see. Can I copy this? Let's try it. Let me see. Control C. If I go into Word, let's insert below. Let's see if I Control V this. Now I say that the IQR equals to 57.5 minus 50.5, which equals to 7. And then I do the lower fence equals to 50.5 minus 1.5 times 7. What's that, 10.5? So I gotta subtract 10, I get 40. So yeah, 40, so this is 40, right? The upper fence equals to, what's Q3? 57.5 plus 1.5 times 7, which equals to, let's see, 57, 67, 68. So it looks like, as long as my math is correct, I'm doing it in my head, it looks like those are the lower and upper bounds for the fences. So let's see, if we go back to the data, anything outside of those values, like smaller than 40 or bigger than 68, will be considered an outlier. Now, if I go to the data, I kind of want to see the data in order, so I'm just going to go to data, sort, and I'm just going to select a column. Then press compute. I'll just change this to variable 1. Now, variable 1 is ascending. Okay, cool. So 42 is the smallest, and what? 69 is the biggest? So let's go here. So 42, okay, so the min equals to 42, and the max equals to what? What did we say? 69? Now, we saw that there was only one. I mean, the next value is 68, so that wouldn't be an outlier, so 69 would be an outlier, and then 42 is bigger than 40, so okay, so it looks like 69 is pretty much the only thing that's an outlier, so we have to write that. 6, so just go like this. 69 is the only outlier. Note that it is bigger than the upper fence. That's it. That was use the IQR. Is that another question? 16. These numbers are probably off. Control. Okay, so I'm gonna right click, insert below. Hey, it didn't do anything. For some reason it didn't work, or what? Oh, maybe I'm way down here. Okay. 16, 17. Gotta be done soon. Come on now, we gotta be done soon. I think this is the last one. Yay. Alright, look. For this one. Find the average age. Find the average age. So this, we're gonna grab it. This is look, this is a frequency distribution. This is summarized data. So when we're trying to find the average, we can't average these values here. These are frequencies. So obviously the biggest numbers are way down here, like way down here. So like, okay, the average should be somewhere low or somewhere big, right? Something in the 40s. The average should be maybe 40 or something. So we're gonna grab this data and just find the mean of grouped data. How did we do that again? Let's see, go here. I'm gonna put it right here. Wow, I put it way down there. Why? I'm gonna go way up here, Control V. Let me grab it and just see if I can move it. Control X, then Control V. Okay, that works. Now, cool stuff. Let's see, these are the bin, that's the bins. These are like the frequency. So I want to find the mean. So summary stats is how we usually find the mean. We just go to columns, right? But this time we're gonna go to groups. And the bins are gonna be bins, and the counts are gonna be frequency, and that's it. I like to do the midpoints. Well, the book we have to kind of, it's more common. Consecutive lower limits, lower class limits would be to find the midpoints. We're gonna do 10, between 10 and 15, not 10 and 14. The limits are 10 and 14 if we did limits, but we're gonna do 10 and 15, so 12.5 for the midpoint on this one. It's more correct. What do we want, the mean? That's all we want is the mean, so compute. There you have it. 36 point, there, that. So Control C, go over here. Control V, I guess it was only was that? Yeah, it's just a number. That, in fact, this question is asked, it's just a numerical question. Okay, there you have it. We're done. That is test 1, the statistics. I hope that helps. All right, take care.